3.1 Functions. So a relation, it has something to do with functions. So let's go into what a relation is. A relation is a correspondence between two sets, a set X called the domain and a set Y called the range. In a relation, each element from the domain corresponds to at least one element from the range. If X is an element of the domain and Y is an element of the range, and if a relation exists from X to Y, then we say that Y corresponds to X, or that Y depends on X, and we write that X, a little line with an arrow, Y. It is often helpful to think as X as the input and Y as the output. A relation can be expressed verbally. It can be expressed using numbers or tables, or a set of ordered pairs. It could be expressed using graphs, so plotting X and Y's. It can be expressed by something that's called a map, by drawing arrows from an element in the domain to the correspondence element in the range. A relation is considered a function when no X values repeat. So a relation, simply stated, a relation is just a set of numbers. That's all it is. It's just a set of numbers. But in our case, it's a set of numbers where X values don't repeat, and we're talking about functions. So that's when it's a function, when no X values repeat. That is all you're looking for, is no X's repeat. That's it. Let's talk about how we can, I just have this written down already. It's something you can copy. So if you want to pause, copy, and then press play, and then I'll explain it. So a verbal description of a relation is given. The average retail price of gas in the U.S. has changed over the years. In 2010, the average cost of 1 gallon of gas was $2.78. In 2012, it was $3.62. In 2014, it was $3.36. In 2016, it was $2.14. In 2018, $2.72. Using year as input and price as output, what is the domain? What is the range of the relation? So it told you that year is input, and we know input is always domain. Then it told us price was the output, and output is always the range, which is always Y. Because X is what you put in, and Y is what you get out of it, because you plug in X to solve for Y. So all of our domain values, they represent years, so we list all of our years, 2010, 2012, 14, 16, 18. Then our range represented the price, so we list all the prices, so 278, 362, 336, 214, and 272. So that's part A, just to list it as a relation. A relation is a set, and a set will always have these little squigglies. They're called braces. So a set will always have these braces. That's how you know it's a set. And since no X values repeat, this is a function. I wasn't asking that, but I just wanted to tell you. All right, B is to express the relation as a set of ordered pairs. So now we want to list it as ordered pair. An ordered pair is always X and Y. And we always use parentheses, right? So we just combine them to the correlating price and year. So 2010, 278, 2012, 362, all the way to 2018, 2.72. Mapping, to express this relation as mapping, so part C, mapping is a T-chart. It's a T-chart with arrows. So the reason why we draw the arrows is to make it known that 2010 goes with 278, 2012 goes to 362, and so on. So this was our X, this was our Y. Part D was to express the relation as a graph. So we have our graph. Time represented the input, and that represented X. Y represented output, and the output was the price. So 2010 it was 272, or 278, which is about right here. 2012, the approximate parse of gas was 362, so that's about 362, and so on. Now, we don't connect the dots. The reason why we don't connect the dots is because this right here is 2013. Do I know the value of 2013? I don't, and I cannot assume it. I only have the values of 2010, 12, 14, 16, and 18, so I cannot connect the dots. I can't do this because I don't know how much it was in 2013. I don't know how much it was in 2017. So we're not allowed to do stuff like that. Alrighty, example 2. Determine whether the relation given by a mapping is a function. So we're given a chart. Let's determine if it's a function or not and list the domain and range. So we have menu item and price. So menu item, that's the left side. The left side is always going to be our x's, and remember that's always domain. So our domain is various types of tacos and other types of food. Our right side, the right side will always be the y, which stands for range. So our range stands for prices. So we have, think about this logically. If you're at a restaurant, can you order something that has the same price? Like, I can order a taco and a burrito, and it could be the same price, right? That's possible. So this is a function. Yes, it's a function because this is possible. Also, see how none of these go twice to an x? This is what it would look like. That's what it would look like for it not to be a function. So you see how beef taco cost both of these? It's not. If you only have one beef taco, you're not going to make it cost more. But what if you're saying, well, what if it's like a small taco and a large taco? That's a different scenario because one is a small one is a large one. So they're different items. So an item, the same item, cannot cost two different prices. We list our domain, which is our menu items. That stands for X. So all of our menu items, I abbreviated. You are allowed to do that. And then our range, which is our Y's, were price. And you have to put the full price because we're talking about money here. And it is a function because none of the X's repeat. For B, we have student stands for our X's, which is our domain. College admittance stands for Y's, which is our range. So our domain are all of the students. So Aaron, Christina, Anton, and George, I abbreviated. Then we have our college admittance, which is the range. So Princeton, Duke, Stanford, MIT. And this is not a function because see how Princeton and Aaron and Duke and Aaron? So I like to think of this as if Erin is admitted to Princeton and Duke, can she technically go to both colleges? She cannot. She can only go to one of the colleges. She can either go to Princeton or she can go to Duke. Also, Erin goes twice to one side. X shares two Y's. You're not allowed to do that. X cannot share two Y's. So this is not a function. All right, example 3, determine whether a relation given by a set of ordered pairs is a function. So what we're going to be doing when we're given a set of ordered pairs, we only look at our x's. So if we look at our x's, we have 1, 3, 5, and 9. None of those numbers are the same. So A is a function. Let's go to B. 2, 5, 7, 1. None of those numbers are the same, so B is a function. So for C, we're going to find the domain and range and also determine if it's a function. So if we look at all our numbers, we have -5, -2, 3, 2, -5. Nope, it is not a function because -5 repeats. Our domain is all the x's, the range, all the y's. You never write a number twice. Just write it once. If it repeats, you never write it twice. Example 4. determine whether an equation is a function. So we're going to determine whether the equation y equals 3x plus 7 defines y as a function of x. So when we look at equations, we need to do one thing to determine if it's a function or not. So I'm going to do example 4 and 5 and kind of go back to them both and explain why they're different. So the first thing that we need to do, we need to solve for y. Not solve for y. So in our equation, we have y equals 3x plus 7. We need to solve for y. Y is already solved for. So I'm actually going to let you guys know that y is already solved for. Since y is already solved for, we need to see how many things does it equal. So if we look to the right, y only equals one thing. So y is equal to only one value. Because it's only one value. If I plugged in x, so if I said x is 1, it would be 3 times 1 plus 7, which is 10. So you see how it only equals one value? That's what I mean by one value. So since it equals only one value, this is a function. Let's do example 5, and then you'll see you'll really start to break down what that means. So example 5, let's determine whether this equation is a function. So no matter what, we just want to solve for y. So we need to get y by itself. So to do that, I'm going to subtract 6x over. And when we do, we have 3y squared equals 2 minus 6x. We divide everything by 3. And when we do, we're left with y squared equals 2/3 minus 2x. We still need to solve for y, so we're going to square root everything. And remember, when we square root, we get y equals positive negative square root of 2/3 minus 2x. So technically, this is y equals positive 2/3 minus 2x and y equals negative 2/3 minus 2x. So y equals two things. Y equals two solutions. Since y equals to two values, this is not a function. Because what we're saying, if x equals a number, we're going to get a positive number and a negative number. So that's not a function because it shares something. Also, y squared is never a function. Ever. Ever, ever, ever. Y squared. If it has y squared in it, it doesn't matter what it looks like. If it has y squared, not a function. Unless it cancels itself out, but that's a really rare opportunity. Y squared, not a function. All right, let's use function notation, find the value of a function. So finding the value of a function is plugging it in, plug and chug, also known as a substitution. So if f is a function, then for each number x in the domain, the corresponding number y in the range is designated by the symbol f of x. So it's read f of x. And rewrite it f of x. Remember, y is the same thing as f of x. But if we're given f of x, it lets us know it's a function. When a function is expressed in this way, we are using something called function notation. We refer to f of x as the value of the function f at the number x. For example, the function y equals 2x minus 5 may be written using function notation as y equals f of x, and that equals 2x minus 5. Let's find function values. So this usually is f of x. So isn't that where the x is? So we're saying x is 2. That means we're just going to plug 2 into x, into the original equation we're given. So into this equation that we're given, we're going to plug in x at 2. So f of x, remember, that just means y. So we have y equals 2 times x squared minus 5x. And in that x, I'm plugging in 2. Simplify. So 2 times squared is 4. 2 times 4 is 8. So 8 minus 10, we get negative 2. So our final answer is f of 2 equals negative 2. This is our x, this is our y. What we're saying is we plugged in 2 and we get negative 2. We plug in 2 for x, we get negative 2. All right, let's do this again for part B. So part B, it wants f of x. F of x that's what the function is. That's what it stands for. So f of x is 2x squared minus 5x. And then we're going to add that to f of 2. Didn't we already do f of 2? We totally did. We did it in part A. F of 2, that's the answer. It was negative 2. So we already have that answer. It's from part A. So since that's from part A, let's work smarter, not harder, and just simplify. So let's get rid of all these parentheses. We don't need them anymore. We have 2x squared minus 5x minus 2. And that's it. That's all we can do. We can't factor. We can't simplify anymore. So f of x plus f of 2 equals 2x squared minus 5x minus 2. So what we did is we took the function and we added that to whatever f of 2 is. So do you notice with part A, when it's on the inside, the number is on the inside, we put it on the inside. When the number is on the outside, guess what? We put it on the outside. Math makes sense sometimes. I agree with you, sometimes it doesn't make sense. But for the most part, I like to think it makes sense. So what we're going to do is we're going to distribute, I don't want to use that harsh red. We can distribute 2 to the function. So we have 2 times the function. The function is 2x squared minus 5x. We simplify. So we have 2 times the function equals 4x squared minus 10x. We don't take a greatest common factor out. That's our final answer. This is part D. I want you to pause this, do it on your own. It's very similar to what we already just did. So pause it, do it on your own, and let's see if we can get the answer together. Okay, I hope you paused it. Welcome back. So it's on the outside. Since it's on the outside, that means it's going to stay on the outside. So negative times the function. So the function is 2x squared minus 5x. We're going to distribute. So negative f of x equals negative 2x squared plus 10x. Awesome. Alrighty, part E, f of x plus h. So that's on the inside of parentheses. Since it's on the inside of parentheses, we're going to plug it in for x. I'm going to rewrite our original functions. We have y equals 2x squared minus 5x. This is where we're going to plug it in for every x. So we have y equals 2 blank squared minus 5 blank. And in the blank, we're plugging in x plus h. So x plus h, x plus h. Now we need to simplify. We need to simplify because x plus h squared is x plus h, x plus h. We can go ahead and distribute this negative 5. So when we do, we have negative 5x minus 5h. We need to FOIL. I'm not going to show you how to FOIL. You should know how to FOIL. If you don't and you struggle with it, that's okay. If you struggle with foiling, let me know. I have videos. I can send you videos. I can send you worksheets. You could practice. So we FOIL, and when we do, we get x squared plus 2xh plus blah, 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 plus h squared, all minus 5x minus 5h. We're going to distribute the 2. And we have 2x squared plus 4xh plus 2h squared minus 5x minus 5h. Can we combine anything? Is anything the same variables? There's not. That's it. That's our answer. Yep, it's weird. It's wonky looking, but guess what? That's fine. Sometimes answers are going to be long. Sometimes answers are going to look wrong. Sometimes they're going to look weird. It's all good. X plus h squared, it's super common in higher level math. It has something to do with the slope of a secant line. So when you get to trig and calculus and stuff like that and pre-calc, you're going to see x plus h squared a lot. So it's something that if you're going on to those higher level math classes, just memorize it. Memorize x plus h squared. And some of you probably had some issues foiling x plus h squared. So I'm going to show you how to foil x plus h squared. So this is technically x plus h, x plus h. So our first one, we have x times x is x squared. Outside, x times x, blah, 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 x times h is xh. Inner, x times h, or excuse me, h times x, it is always going to be xh. The x is always going to go first. Don't know why we do it that way. We just do it that way. But seriously, I have no idea why we put the x first. But x always goes first when it's h times x. And then last we have h times h, which is h squared. So we combine like terms in the middle. We have x squared plus, we have two of these, so 2xh plus h squared. So just have that memorized. Important facts about functions. For each x in the domain of function f, there is exactly one image f of x in the range. However, more than one x in the domain can have the same image in the range, meaning no repeating x's. That is literally all that's saying, is no repeating x values. Okay. F is the symbol that we use to denote the function. It is symbolic of the equation rule that we use to get from x in the domain of f of x in the range. If y equals f of x, then x is the independent variable, or the argument of f, and y, or f of x, is the dependent variable, or the value of f at x. So y is dependent and x is independent, because without x, we have no y. We need to plug in x to get y, so y is 100% dependent on x. Difference quotient. You do not need to memorize this. This will be given. I will give this to you. You're going to be given the difference quotient. It's a formula. The difference quotient, that is the slope of a secant line. You see that x plus h? Yep, I know. That's why we're talking about it. That's why we talked about it. So find the difference quotient. I will be doing this in one of our Zoom sessions. I highly encourage you come to that. I'll let you know when we'll be doing this. But yeah, you're going to need to see this a few times. And I promise to do several examples using difference quotient in the Zoom session that's going to follow this, or maybe a little before. It's May 17th when I'm recording this. Chapter 3 isn't until the end of May, early June. So finding the difference quotient, we have two parts. We have x squared minus 1, and then we have 1 over x. So let's do part A first. We have f of x equals x squared minus 1. So I just want you to put your pencil down, or your pen. I hate pencils too. If you're like, ugh, pencils, feel you. Put your writing utensil down, and I just want you to look at me do this. I just want you to look at the screen. Afterwards, pause it at the end, and then copy it. That's how I want you to approach A and B. So when I get to B, put your pencil down, watch me do it, pause it, then copy. So our difference quotient is here. It's f of x plus h minus f of x minus h. It's right here. So it's a formula. Now, don't do this to your paper because you can't erase it, and I told you not to write. pretend this isn't here. Pretend none of that is there. Seriously, like pretend it's not there. So if that's not there, aren't we just doing f of x plus h? Right? That is what we're doing. And don't we just plug that in for x? So let's plug it in for x. So we have x squared minus 1, and in that x, we have x plus h. So we did that. Now, we know there's not just that there, there's other things. So now what we're going to do is pretend none of this is here. So pretend none of that is there. What we have is negative f of x. So don't we know what negative f of x stands for? Doesn't it just mean minus the function? And the function is x squared minus 1. Then I'm going to pretend none of this is here. It's just all over h. That is how we use the difference quotient. So let's solve it. And again, in that Zoom session, I'm going to be doing this a lot. We need the practice. So we need to simplify. Let's just simplify. What we're going to do first is x plus h squared, which we know. We should know x plus h squared is x squared plus 2xh plus h squared. We know that. And it's all minus 1. We're going to distribute this negative. So we have negative x squared plus 1. And don't forget to stomp on your right foot. Don't forget it. Don't forget the h. I always forget that h. And every time, I swear to you, every time I have a paper test on this section, y'all forget the h. And it just drives me insane. Why does it drive me insane? Because you know what to do. You're just forgetting the h. It's such a little thing to miss, right? Of course we would do that. Anyways, don't forget that h. Let's see if we can cancel anything out. We have x squared and negative x squares. Those cancel. We have negative 1 and positive 1. Those cancel. So let's just write what we have left over. We have 2xh plus h squared. That's it. That's all we have left over. That's all over h. Let's see if anything on top, what we can do on top. On top, they have h in common. So we have to keep simplifying. So keep simplifying means factor, combine like terms, stuff like that. So we're going to take the h out, and when we do, we're left with 2x plus h all over h. Since there are no pluses and minuses right here, there's no plus or minus right there, right? We're allowed to cancel out those h's. So our final answer is 2x plus h. The answer will not make any sense. It's going to make sense if you take pre-calc and trig, and well, not even trig. You don't even talk about this in trig. You talk about it in calculus. But right now, you just need to know how to work with it. So you know how we know how to add and subtract, multiply and divide, and we just do it willy-nilly now? It's like the equivalent form of that, where you're going to have to know how to do this when you get to calculus. You'll talk about it again within the first couple weeks of pre-calc. This is just your first time talking about the difference quotient. I want to talk about the answer real quick. Do you notice that we started off with a binomial? What did we end with? A binomial. We start with a binomial. We end with a binomial. That's all I'm going to say. All right, part B. We have a fraction. So if we start with a fraction, do you think we're going to end with a fraction? Let's see. All right, part B. So part B, our function is f of x equals 1 over x. And I'm just going to rewrite our difference quotient. All right, again, I want you to pause with the writing. Don't pause the video. Put your pencil down and watch me do this. Then after we're done, pause it, copy. All right, we're going to do the same procedure. So we're going to pretend none of this is here. So pretend that none of that is there. So all we're talking about is x plus h. And we know what to do with that. We just plug it in as x. So we have 1 over blank, and the blank is x plus h. Okay, so we did that. Now we pretend none of this is here. So pretend none of that is there. We have minus f of x. So minus the function, and the function is 1 over x. And don't forget it, it's all over h. So all over h. Okay. We have to simplify. So the top is telling us to subtract. Since the top is telling us to subtract, we need to subtract them. It's telling us. That's what the minus sign is. It's telling us subtract the term from this term. So in order to subtract, we need to get the same bottom. So times x times x times x plus h times x plus h. So our common denominator is x plus h. We just multiply the denominators together. That's it. Just multiply them together. That's your LCD. So we're going to get our LCDs and apply them. So we have x times 1 is x over x plus h. And that's minus, actually, let's just do this now. We have a negative 1. That's a negative 1. So we have to multiply a negative out. And when we multiply a negative out, this becomes positive, and on top we'll have negative x minus h over x plus h. And don't forget it, all over h. Now we combine like terms on top. There we go. So to combine like terms on, that's gonna happen, I'm so sorry guys. When we combine like terms on top, the x's get rid of each other, so what we're left with is negative h over x plus h, and don't forget it, it's all over h. We keep, change, flip, remember? So just as a reminder, this sign right here just means division. So we have x over x plus h divided by h over 1. Keep, change, flip. So we keep the first one. We change the sign. We flip the second one. We can simplify. And when we do, we're left with, sorry, that was a negative h. We're left with negative 1 over x plus h. All right, we are almost done. We have 2 more examples left. I know this is a really long section. We usually do it in 2 days in a class. So if you need to pause after this and be like, whew, that was a lot, I get it. So if you need to, pause it, do some of your homework that you already covered, because it usually goes in order in what we do. But do what you can on your homework, and I do agree that it might be smarter to pause, come back another time today or another day, but very soon. Don't wait too long on this. All right, domain. Domain is what x can and cannot be. So that's super important when we plug in x. We need to know what can x be. So there's only 4 scenarios ever. There's only 4 scenarios, and as we go through them, I'm actually going to be explaining as we go along. So I want to let you know now that this is A, this is B, C, and D. So that's, each example represents one of the rules, one of the scenarios. But I'm going to explain them as we go along. So let's find the domain. That was a copy and paste error. So you want to ask yourself 2 questions. First question, is there a radical? In part A, no radical. That's a radical, no radical. Okay, second question. Are there any fractions with the letter in the bottom? Nope. If that's the case, all real numbers. Those are all your ways that you can write all real numbers. Negative infinity to positive infinity. You can say all real numbers. You can say x such that x is any real number, or you can have an r with a line through it. They all mean all real numbers. So let's do part B and ask ourselves the same exact questions. In part B, is there a radical? Nope, no radical. Awesome. Let's keep moving on. Now you ask yourself, is there a fraction with a variable in the denominator? Yes, there is. We have a fraction with a variable in the denominator. So what we do is we set the denominator cannot equal to 0. Why? Because in a fraction, the bottom cannot be 0. It's undefined. It's impossible. So we have to know what is x. What is x after we plug it in? What makes it 0 in the bottom? So we want to say, when we put the bottom, we just say it cannot equal 0. So we're saying bottom can't equal 0. That's what we're doing. That's how we set this up. Bottom can't equal 0. And solve for x. So we have x squared equals positive 4. We square root it, so we get x equals positive negative 2. That means x cannot be negative 2, and it cannot be positive 2. Because if we plugged it back into x, the bottom would be 0, and that's not real. That's undefined. It's not even imaginary. It's just impossible. Interval notation. So this little squiggly, the braces, remember, that's called a set. So interval, which we have talked about before. So to write this in interval notation, I'll show you with the picture. So we have two things that it can't be x. It can't be negative 2, and it can't be 2. So we read this graph to figure out our intervals. Our first interval is coming from negative infinity. And an x means stop. Like if you saw a big X, you would stop at a door. So it's negative infinity to negative 2. The stop always means union. So union, negative 2 to positive 2. The stop means union. And then 2 to infinity. It is always like that for interval notation if you have two numbers. It is always negative infinity number, union number, union number, infinity. Always like that. Alrighty, part C. So part C, we ask ourselves two questions. Are there any radicals? Yes, we have one. Then we have to ask ourselves again, are there any fractions with variables in the denominator? Nope. So for part C, we only have a radical. So what we do when we have radicals is we set the inside greater than or equal to 0. Why greater than or equal to 0? Because inside radicals, you cannot have negative numbers. So we need to know what makes the inside greater than or equal to 0. Because we do not have square roots to negative numbers. It's imaginary. So let's solve. We're going to subtract 4, so we have negative 3t is greater than or equal to negative 4. Divide by negative 3. So since we divide by a negative, don't forget we have to flip the sign. So we have t is now less than or equal to positive 4/3. So we can write this in set notation, x such that t, if you do that, it's okay, it happens. T such that t is less than or equal to 4/3. Or in interval notation, it would be negative infinity 4/3 bracket. That is straight up from chapter 1.5 and 1.6. Alrighty, part D. So part D, you still have to ask yourself the two questions in part D. Do we have a radical? Yes. Do we have a fraction with a variable in the denominator? Yes. That means we have to do both things. So that means we have to set inside the radical greater than or equal to 0, and we have to set the bottom can't be 0. So we get x cannot be 5. And we subtract 12, so we have 3x is less or greater than or equal to negative 12. Divide by 3. When we divide by 3, we get x is greater than or equal to negative 4. So in set builder notation, it would be x such that x is greater than or equal to